Number 50. Alright, we got a circumscribed circle. So we see that and we got to be thinking circumcenter. So, and like I said a few slides ago, you got to remember that the circumcenter goes along with your perpendicular bisectors. So please review those. Know what goes with what. There's only 4 of them. That's it. You can remember 4 things. So circumcenter and perpendicular bisectors. So the correct answer should be D. B is the intersection of the perpendicular bisectors. Alright, 51. This is a fun question. I like these a lot. Which could be the length of AB, of the triangle ABC? So we don't know it, so let's call it X. And let's figure out what some possible lengths for it could be. I know that in a triangle, 2 sides have to be greater than the third. So that means 17 plus 9 has to be greater than X. Okay, then let's set up a couple more inequalities. 17 plus X has to be greater than 9. And one more, 9 plus X has to be greater than 17. Let's solve these all for X. 26 is greater than X. Subtract 17 and X is greater than negative 8. Subtract 9 and X is greater than 8. So this one doesn't help us at all. Obviously X is greater than negative 8. Okay. So I know that X has to be between 26 and 8. I could write my single inequality like this. X is greater than 8 and less than 26. So could X be 26? No, because it has to be less than 26. Could X be 8? No, because it's greater than 8. Could X be 7? No, that's stupid. So it's got to be C. 9 falls between 8 and 26, so 9 is our answer. Discuss how you would know the triangles are similar. What theorem would justify your conclusion? Alright guys, look at this thing. We know that side, we know that side, we know a right angle, and you know that we have vertical angles. So, you know an angle, and that's all you need to prove triangles similar. They're similar by angle. Alrighty. Given points A, 4, 5, and B, negative 4, 11, find the midpoint of A and B. Alright, well, to find the midpoint, you have the formula in your reference sheet, but hopefully you know that you're just taking the average of the x's, so x1 plus x2 over 2, and the average of your y's, y1 plus y2 over 2. Alrighty, so our midpoint is x1, 4, plus x2, so 4 plus negative 4 over 2. And y1, 5 plus 11 over 2. So our midpoint is 4 plus negative 4 is 0, and 5 plus 11 is 16 divided by 2, and our midpoint is going to be 0, 8. Bam! Alright, 54 is the same kind of question, except for we're just looking for the y value in the midpoint. It already did the x1 for us, which is cool. So let's just do half of it. Let's just do the y part. So y1 plus y2 over 2. And they're saying that that's going to be called k. So y1 is, wait, didn't we just do that? 5 and 11, 5 and 11. So the value of k should be 8. That was weird. Oh, okay, almost there. A couple more questions. Choose the concave quadrilateral. Well, concave means it goes in like a cave. So it's going to be C. And everything we deal with in our class is convex. So concave means go in like a cave, and the stuff that we're used to seeing is all convex, like A, B, and D. Number 57. This is a regular pentagon, so I know that all of these angles are the same. So if I want to find one of them, I need to know the sum of all of them. So I use the formula n minus 2 times 180. And then when I know all of them, I can divide it by the number of angles there are. So since this is a pentagon, we're going to do 5 minus 2. N is 5. And divide it by 5. So we got 3 times 180 over 5. So it's going to be 540 divided by 5, which I believe is going to be D108. Again, this is on your reference sheet. Woohoo, almost done, so close. Number 58, to prove a parallelogram is a rectangle, what would you need to know? All sides are congruent? No. All sides are right angle. Ooh, that's pretty good, I like that. Opposite sides are parallel? Well, that's not enough to prove it's a rectangle. That would just prove that it's, at the very least, parallelogram. Diagonals bisect each other. Well, that's pretty handy, but the only thing we need to know is that all angles are right angles. 59. To prove a parallelogram is a rhombus, which would be sufficient. And you guys know rhombuses are way awesome because all of their sides are congruent. The last question. Woohoo, we made it. It looks like a lot of work, but it really isn't. Angle B and angle D are right angles. Okay, let's draw it. And the reason for that is it's given. Okay, so why would angle B be congruent to angle D? Well, it should make sense that if they're right angles, they're both 90 degrees, so they're both congruent. So we're just going to say that all right angles are congruent. Okay, and then down here it says ACB. Well, first let's write that, because AB is congruent to DE. But down here it says ACB, angle ACB, this guy right here, is congruent to ECD, ECD, so this angle. So those two angles are congruent, and why? I think everybody knows that. They are vertical angles. So ABC would be congruent to, well, A matches up with E, B and D, and C and C. So E, D, C. And Y, let's see, we have a side, angle, angle. So we'll call it AAS. And guess what? We're totally done. Guys, if you need help with anything, come see me in my room before school, after school. Just don't bother me during lunch. Just kidding. Whenever you need help, come get it, okay?